In the vastness of space, there are few things as awe-inspiring or as intimately tied to our existence as the sun. This gargantuan ball of glowing plasma has burned for billions of years, anchoring our solar system and providing the energy that sustains life on Earth. But like all things in the universe, the sun's journey is not eternal. One day, it too will reach the end of its life, embarking on a slow transformation from the radiant star we know today into something far more mysterious and eerie, a white dwarf. The fate of the sun, and the processes it will undergo as it shifts from a main sequence star to a white dwarf, is one of the great cosmic stories, a tale that spans billions of years and speaks to the nature of stellar evolution. It's a journey of birth, growth, death, and a final lingering ghostly existence. As we explore the sun's future, we uncover profound truths not just about stars but about the fate of solar systems, planets, and perhaps even life itself. What will happen when the sun dies, and what does this mean for the Earth and everything we know? But before we continue, if you like this type of videos, please subscribe to the channel and comment. To understand the sun's fate, we must first understand what it is today, a main sequence star. In the grand classification of stars, the sun is relatively average. It is not the most massive star, nor the hottest, nor the brightest. But it is a perfectly stable G-type main sequence star, burning hydrogen in its core to produce energy. This phase, where the sun converts hydrogen into helium through nuclear fusion, is the longest and most stable period of a star's life. The sun is currently about 4.6 billion years old and is roughly halfway through its main sequence phase. This phase will last for approximately another 5 billion years, during which the sun will continue to shine steadily, providing the energy needed for life on Earth. However, once the hydrogen fuel in the sun's core is depleted, the story takes a dramatic turn. As the sun exhausts the hydrogen in its core, the delicate balance between gravity, which pulls inward, and the pressure from nuclear fusion, which pushes outward, will begin to shift. The core will contract under gravity, becoming denser and hotter. This increase in temperature will ignite hydrogen in the shell surrounding the core, causing the outer layers of the sun to expand. As a result, the sun will swell into a red giant, a phase that marks the beginning of its slow demise. During this time, the sun will grow so large that it may engulf the inner planets of the solar system, including Mercury, Venus, and possibly even Earth. The transformation into a red giant is a spectacular but destructive phase, and it marks a significant milestone in the life of a star. The sun, once a steady beacon of life, will become an enormous, bloated star that poses a deadly threat to any planets caught in its swollen grasp. The red giant phase will not last forever, however. As the sun continues to burn helium in its core, fusing it into heavier elements like carbon and oxygen, the nuclear reactions will gradually slow down. The outer layers of the sun will be ejected into space, creating what is known as a planetary nebula, a glowing shell of gas and dust that will briefly illuminate the surrounding regions of space. This process is one of the most beautiful endings for a star, with the planetary nebula glowing for tens of thousands of years, creating a cosmic masterpiece in the dark expanse of the universe. The ejection of the outer layers of the sun will leave behind a hot, dense core, a white dwarf. This white dwarf, a remnant of the once mighty sun, is what will remain for the rest of eternity. White dwarfs are incredibly dense, with a mass comparable to the sun's but compressed into a volume no larger than Earth. The sun's transformation into a white dwarf marks the end of its nuclear fusion processes, and it will no longer produce energy. Instead, it will gradually cool and fade over billions of years, eventually becoming a cold, dark, dead object known as a black dwarf. But the timescales for this cooling process are so vast that it will take longer than the current age of the universe for a white dwarf to cool completely. So, what does this all mean for the Earth and the solar system? The transformation of the sun into a red giant will have catastrophic effects on our planet. As the sun expands, it will become significantly hotter, and the habitable zone, the region where liquid water can exist, will shift outward. Long before the sun engulfs the Earth, the increasing heat will cause our oceans to evaporate, the atmosphere to be stripped away, and the surface to become scorched and uninhabitable. Life, as we know it, will be extinguished long before the sun's final death throes. If humanity still exists by this time, we will need to have found a new home elsewhere in the universe, far from the dying sun. The fate of the outer planets, such as Jupiter and Saturn, is slightly different. These gas giants may survive the red giant phase, but they will be profoundly affected. The outer layers of the Sun, ejected during the planetary nebula phase, may push these planets further out into space. Additionally, the loss of the Sun's mass will weaken its gravitational pull, causing the orbits of the remaining planets to change. The solar system will become a much colder and more distant place, with the Sun reduced to a faint white dwarf in the sky. The study of the Sun's future is not just an exercise in understanding our own solar system, but it also provides valuable insights into the evolution of stars in general. The Sun's life cycle is representative of many other stars in the universe, particularly those of similar mass. By studying the Sun, astronomers can make predictions about the fates of countless other stars, as well as the planetary systems that orbit them. The story of the Sun's transformation from a main sequence star to a white dwarf is a universal narrative, played out on cosmic scales across the galaxy. However, the transition to a white dwarf is not the end of the story. White dwarfs themselves are fascinating objects, with unique physical properties that challenge our understanding of matter and energy. They are composed of degenerate matter, where electrons are packed so closely together that they resist further compression. This quantum mechanical phenomenon, known as electron degeneracy pressure, is what prevents a white dwarf from collapsing under its own gravity. Despite their small size, white dwarfs can have incredibly strong gravitational fields, which can have intriguing effects on nearby objects. White dwarfs also play a key role in some of the most dramatic events in the universe, type Ia supernovae. In binary star systems, where a white dwarf orbits closely with another star, the white dwarf can accumulate material from its companion star. If enough mass is accumulated, the white dwarf can reach a critical point, triggering a runaway fusion reaction that causes it to explode as a supernova. These supernovae are not only spectacular in their own right, but they also serve as important tools for measuring distances in the universe, helping astronomers to map the expansion of the cosmos. As we contemplate the eventual fate of the Sun, we are reminded of the vast timescales on which the universe operates. The processes that govern the life and death of stars are slow, unfolding over billions of years. And yet, within these cosmic events lies the story of our own existence. The atoms that make up our bodies, the Earth, and everything around us were forged in the hearts of stars. Stellar evolution is not just a distant, abstract process. It is the very mechanism by which the elements of life were created. The death of the Sun will mark the end of an era for our solar system, but it is also a reminder of the cyclical nature of the universe, where death and destruction lead to new beginnings. In the distant future, when the Sun has faded into a white dwarf, and the remnants of our solar system have drifted into the cold depths of space, the story of our star will continue to echo across the cosmos. The light from the Sun's red giant phase will travel outward, illuminating distant corners of the universe long after the Sun itself has dimmed. In a way, the fate of the Sun is a microcosm of the universe itself, a journey from birth to death, filled with mystery, beauty, and transformation. As we continue to unravel the fate of the Sun, it becomes evident that the transformations it will undergo have implications that reach far beyond the solar system. The transition from a stable main sequence star to a red giant, and eventually to a white dwarf, is part of the broader narrative of stellar evolution, a story that mirrors the life cycles of stars throughout the universe. But the Sun's death is not an isolated event. It will take the solar system, and everything within it, along for the ride. The delicate balance of gravitational forces, the radiation of solar energy, and the stability of planetary orbits will all be thrown into chaos as the Sun enters its dying stages. As the Sun transitions into a red giant, one of the most profound effects will be the ejection of its outer layers. This ejection will release vast amounts of material into space, contributing to the formation of a planetary nebula. These nebulae are among the most beautiful phenomena in the universe, intricate clouds of gas and dust, illuminated by the remaining hot core of the dying star. Each planetary nebula is unique, shaped by the complex interactions between the star's magnetic fields, stellar winds, and surrounding environment. The material ejected during this phase will eventually disperse into space, seeding the interstellar medium with the elements produced during the Sun's life. These elements, including carbon, oxygen, and other heavier elements, are the building blocks of future generations of stars and planets. In fact, the very elements that make up Earth and life itself were once formed in the cores of previous generations of stars. The death of the Sun, while catastrophic for the solar system, will contribute to the ongoing process of stellar recycling that fuels the cosmos. This cycle of birth, death, and rebirth is a fundamental aspect of the universe, and it ensures that the materials necessary for life continue to be available long after the original stars have died. One of the most fascinating aspects of the Sun's transformation is the process of nucleosynthesis, the creation of new elements within stars. During its red giant phase, the Sun will undergo helium fusion, where helium atoms fuse to form heavier elements such as carbon and oxygen. This process is critical for the chemical enrichment of the universe, as it provides the raw materials for everything from rocky planets to the complex molecules that form the basis of life. The heavier elements produced in the cores of stars are distributed into space through events like supernovae and planetary nebulae, enriching the interstellar medium and paving the way for the formation of new stars and planetary systems. The planetary nebula phase, while brief in astronomical terms, represents the Sun's final act of creation. The hot core that remains, the future white dwarf, will emit intense ultraviolet radiation that causes the surrounding gas to glow, creating the ethereal, glowing structures that we observe as planetary nebulae. These nebulae are fleeting, lasting only a few tens of thousands of years before they disperse into the interstellar medium. But during their short lifetimes, they serve as poignant reminders of the life cycles of stars and the interconnectedness of the universe. As the Sun sheds its outer layers and the planetary nebula fades, what remains is a white dwarf. This small, dense remnant is all that is left of a once mighty star. White dwarfs are among the strangest objects in the universe, with properties that challenge our understanding of physics. Despite having a mass comparable to that of the Sun, a white dwarf is only about the size of Earth. This incredible density means that a teaspoon of white dwarf material would weigh as much as an entire mountain on Earth. The Sun, once a vast, luminous sphere of plasma, will be reduced to a tiny, faint point of light in the cosmic night. The reason a white dwarf does not collapse under its own immense gravity is due to a quantum mechanical phenomenon known as electron degeneracy pressure. In a white dwarf, the electrons are packed so closely together that the Pauli exclusion principle comes into play, a rule in quantum mechanics that states no two electrons can occupy the same quantum state. This creates a pressure that resists further compression, allowing the white dwarf to remain stable even without the energy generated by nuclear fusion. However, this stability is not permanent. Over billions of years, the white dwarf will slowly cool and fade, eventually becoming a black dwarf, a cold, dark remnant that no longer emits light or heat. But the timescale for this final phase is staggeringly long. In fact, the universe is not yet old enough for any white dwarfs to have cooled into black dwarfs. It will take trillions of years, far longer than the current age of the universe, for the Sun to reach this final, frozen state. By that time, the universe itself will have undergone dramatic changes. Galaxies will have drifted apart, stars will have burned out, and the cosmos will be a much darker and lonelier place. The Sun, once a bright and vibrant star, will be nothing more than a faint memory in the cosmic landscape. The transformation of the Sun into a white dwarf has profound implications for the solar system as a whole. The loss of the Sun's outer layers and the weakening of its gravitational pull will have dramatic effects on the orbits of the remaining planets. The outer planets, such as Jupiter, Saturn, Uranus, and Neptune, will likely survive the red giant phase, but their orbits will become more eccentric and unstable as the Sun loses mass. Over time, these planets may drift farther from the Sun or even be ejected from the solar system entirely. The asteroid belt, Kuiper belt, and Oort cloud will also be affected by the Sun's transformation. These regions of space, filled with rocky and icy bodies, will be bombarded by the ejected material from the dying Sun. Some of these objects may be pushed inward toward the inner solar system, while others may be scattered into interstellar space. The solar system, once a relatively stable and orderly place, will become a chaotic and unpredictable environment as the Sun nears the end of its life. In addition to the physical changes in the solar system, the transformation of the Sun into a white dwarf raises intriguing questions about the future of humanity. If we are still around when the Sun enters its red giant phase, we will need to find a way to survive the extreme changes in the solar environment. The Earth will become uninhabitable long before the Sun engulfs it, so humanity will need to seek out new homes elsewhere in the galaxy. Perhaps by that time, we will have developed the technology to colonize other planets, or even other star systems. The fate of the Sun may serve as a catalyst for humanity to explore the cosmos and ensure our survival beyond the confines of the solar system. Looking beyond our own solar system, the study of the Sun's evolution provides valuable insights into the life cycles of other stars. The Sun is a relatively average star, but its life cycle is representative of many other stars in the universe. By studying the fate of the Sun, astronomers can make predictions about the fates of other stars, particularly those of similar mass. This knowledge helps us understand the broader processes that govern the formation and evolution of galaxies, star clusters, and planetary systems throughout the cosmos. As we contemplate the future of the Sun, we are reminded of the vast timescales on which the universe operates. The changes that will occur in the Sun over the next few billion years are almost unimaginable in human terms, but they are just one small part of the ongoing story of the cosmos. The Sun, like all stars, is a transient object, a brief flash of light in the dark expanse of space. But its legacy will live on in the elements it creates, the planetary systems it shapes, and the distant civilizations it may one day inspire to reach for the stars. The fate of the Sun is a reminder that even the most stable and seemingly eternal objects in the universe are subject to change. Nothing in the cosmos is truly permanent. Everything is in a state of constant flux. The Sun, which has provided light and warmth for billions of years, will one day fade into darkness, leaving behind only a faint echo of its former glory. And yet, in its death, the Sun will contribute to the ongoing cycle of stellar evolution, playing its part in the grand narrative of the universe. As the Sun continues its inexorable journey toward its eventual demise, its impact on the solar system will be both catastrophic and transformative. When we look at the life cycle of stars like the Sun, we see that their evolution mirrors the balance between creation and destruction that permeates the universe. This balance is reflected in the fact that the death of stars, while destructive for the planets and other celestial bodies that orbit them, also gives rise to new opportunities for cosmic evolution. One of the most intriguing aspects of the Sun's later stages is the formation of a white dwarf. A white dwarf is the remnant left after the Sun has shed its outer layers and ceased nuclear fusion in its core. This remnant is an incredibly dense, compact object made almost entirely of electron-degenerate matter. While the Sun, during its main sequence life, shines brightly due to the energy produced from nuclear fusion, a white dwarf is a much dimmer object. It emits only residual thermal energy, which gradually fades over time. However, the transition to a white dwarf is not a simple or sudden event. After the Sun has exhausted the helium in its core during the red giant phase, it will begin to shed its outer layers into space, forming a planetary nebula. The core that remains, now devoid of nuclear fuel, will no longer produce the energy required to counteract gravitational collapse. What's left is the white dwarf, a star that is no longer able to fuse elements, but resists further collapse due to electron degeneracy pressure. As mentioned earlier, electron degeneracy pressure is a fascinating quantum mechanical effect. In simple terms, the Pauli exclusion principle states that two electrons cannot occupy the same quantum state at the same time. This creates a situation in which the electrons in a white dwarf are packed as closely together as quantum mechanics allows, providing enough pressure to counterbalance the immense gravitational forces trying to compress the star further. This phenomenon allows the white dwarf to remain stable for an extraordinary period of time, although it will slowly cool over billions of years. The slow cooling of the white dwarf represents the final phase in the Sun's life. Over time, as the white dwarf radiates away its remaining thermal energy, it will become dimmer and colder. Eventually, after trillions of years, a time frame so vast that it dwarfs the current age of the universe, the white dwarf will cool to the point where it no longer emits any detectable light or heat. At this point, the Sun will have become a black dwarf, a cold, inert object that drifts silently through the galaxy. It is important to note that, to the best of our knowledge, the universe is not yet old enough for any black dwarfs to have formed. The oldest white dwarfs are still in the process of cooling, and it will take far longer than the current age of the universe for them to reach the black dwarf stage. The eventual fate of these objects is one of the many mysteries that astronomers continue to explore. What will happen in the far future, when all the stars in the universe have either become white dwarfs, neutron stars, or black holes? This question leads us into the realm of cosmology, and the ultimate fate of the universe itself. The fate of the Sun also raises questions about the future of life in the solar system. Long before the Sun becomes a white dwarf, life on Earth will have been rendered impossible. As the Sun evolves into a red giant, its outer layers will expand, engulfing the inner planets. The Earth, if not completely consumed by the expanding Sun, will be scorched by its intense heat. The oceans will evaporate, the atmosphere will be stripped away, and any remaining life will be extinguished. Long before this final cataclysm, however, the increasing luminosity of the Sun will have already made Earth uninhabitable. The gradual increase in the Sun's luminosity is a natural consequence of its evolution. As the Sun burns hydrogen in its core, the helium produced from fusion accumulates, altering the Sun's internal structure. Over time, this causes the Sun's core to contract and heat up, leading to a corresponding increase in the rate of fusion. As a result, the Sun's energy output will slowly increase over billions of years. This increase in luminosity will have significant consequences for the Earth's climate. In about 1 billion years, the Earth's surface temperature will rise to the point where the oceans begin to boil away, initiating a runaway greenhouse effect similar to what is observed on Venus. At this stage, life as we know it will no longer be able to survive on Earth. This distant future forces us to confront a difficult question: what will happen to humanity, if it still exists, when the Earth becomes uninhabitable? Will we have developed the technology to migrate to other planets, or even other star systems? Will we have colonized Mars, moons of the outer planets, or perhaps distant exoplanets in neighboring star systems? The fate of the Sun may serve as a powerful motivator for humanity to seek new homes beyond our solar system, ensuring the survival of our species in a universe that is constantly changing. The eventual transformation of the Sun into a white dwarf and the subsequent death of the solar system is not unique to our star. Similar fates await many other stars in the universe. Stars with masses comparable to or smaller than the Sun will follow similar evolutionary paths, becoming red giants and eventually white dwarfs. Larger stars, on the other hand, have more dramatic fates. Massive stars end their lives in spectacular supernova explosions, leaving behind neutron stars or black holes. These stellar remnants, like white dwarfs, are fascinating objects that challenge our understanding of physics and cosmology. The study of white dwarfs and other stellar remnants has provided valuable insights into the ultimate fate of stars and the long-term evolution of the universe. By observing white dwarfs and other star systems, astronomers can learn more about the processes that govern stellar death and the future of our own Sunday. In fact, white dwarfs are among the most common types of stars in the universe, representing the final stage in the life cycles of the majority of stars. Their abundance makes them important objects of study for understanding the broader picture of stellar evolution. As we continue to explore the mysteries of the Sun's fate, we must also consider the broader implications for the universe. The Sun's transformation into a white dwarf is part of the larger story of cosmic evolution, a story in which the forces of gravity, nuclear fusion, and quantum mechanics work together to shape the stars, planets, and galaxies that populate the cosmos. The Sun, like all stars, is a product of these forces, and its eventual death will contribute to the ongoing cycle of stellar birth and death that drives the evolution of the universe. The legacy of the Sun will live on, not only in the white dwarf that remains but also in the material it ejects into space. This material, enriched with the elements produced in the Sun's core, will become part of the interstellar medium, the vast reservoir of gas and dust from which new stars and planets will form. In this way, the Sun's death will contribute to the creation of new worlds, continuing the cycle of stellar evolution that has shaped the universe for billions of years. In addition to its physical legacy, the Sun will also leave behind a legacy of knowledge. For centuries, humanity has studied the Sun, seeking to understand its inner workings and its place in the cosmos. From the earliest observations of sunspots to the modern science of helioseismology, which allows us to probe the Sun's interior, our understanding of the Sun has grown immensely. This knowledge not only enhances our understanding of our own star but also informs our study of other stars throughout the universe. The study of the Sun's fate has implications beyond just the scientific understanding of stellar evolution. It challenges us to think about the long-term future of life, humanity, and the solar system itself. The Sun, despite its essential role in sustaining life on Earth, is not eternal. Its eventual demise forces us to confront the reality of cosmic impermanence. The Sun's journey from a main sequence star to a white dwarf spans billions of years, and although this timeline far exceeds the lifespan of human civilization, it is a reminder of the transient nature of all things in the universe. As the Sun approaches the end of its life, the ejected material from its outer layers will create a planetary nebula, a beautiful yet haunting phenomenon. This nebula, which will surround the dying star, will be visible for a few tens of thousands of years before it disperses into the interstellar medium. Observations of planetary nebulae around other stars provide us with a glimpse of what the Sun's fate might look like from a distance. These nebulae are often breathtaking in their complexity and beauty, with glowing gases and intricate patterns sculpted by the forces at play in the dying star's environment. Planetary nebulae are more than just visually stunning remnants of dying stars. They are also important laboratories for understanding the processes that occur during the final stages of stellar evolution. By studying the light emitted by these nebulae, astronomers can learn about the chemical composition of the ejected material and gain insights into the nucleosynthesis that took place in the star's core during its life. The Sun, like other stars, is responsible for producing many of the elements that are essential to life, such as carbon and oxygen. These elements, forged in the Sun's core through nuclear fusion, will be returned to the interstellar medium when the Sun dies, contributing to the formation of future stars and planets. The Sun's planetary nebula, though short-lived on cosmic timescales, will mark the end of an era for the solar system. By this time, the inner planets, including Earth, will have been scorched or consumed by the expanding Sun during its red giant phase. The outer planets, while spared from direct destruction, will no longer have the same familiar environment. The energy output from the Sun, now a cooling white dwarf, will be vastly reduced. The solar system will be a much colder, darker place, with the surviving planets and moons gradually drifting away as the Sun's gravitational influence weakens over time. As the white dwarf cools and fades, the solar system will continue to evolve in ways that are difficult to predict. One possible scenario involves the eventual interaction between the solar system and passing stars. Over the course of billions of years, gravitational encounters with other stars could perturb the orbits of the planets, leading to potential collisions or ejections from the solar system. The once stable orbits that characterize the solar system during the Sun's main sequence life may become increasingly chaotic as the Sun's influence diminishes. In addition to gravitational interactions, the solar system will also be affected by larger-scale cosmic processes. As the Milky Way galaxy continues to evolve, it will eventually collide with the nearby Andromeda galaxy, creating a massive galactic merger. This event, though still billions of years in the future, will dramatically reshape the structure of both galaxies. The merger will trigger intense bursts of star formation and could potentially disrupt the orbits of stars and planetary systems throughout both galaxies. Although the exact consequences for the solar system are uncertain, the gravitational forces unleashed during the merger could further alter the Sun's position within the galaxy and the fate of its remaining planets. The story of the Sun's life and death is not just about the star itself, but also about the interconnectedness of cosmic events. The Sun's formation, evolution, and eventual death are part of a much larger narrative that includes the birth of the universe in the Big Bang, the formation of galaxies, and the ongoing processes of stellar evolution and planetary formation. The elements that make up the Sun, the planets, and all living things on Earth were created in the hearts of earlier generations of stars, many of which ended their lives in supernova explosions. The cycle of stellar birth and death is one of the fundamental processes that drive the evolution of the universe. One of the most significant breakthroughs in our understanding of the Sun came with the development of the theory of nuclear fusion. In the early 20th century, scientists realized that the Sun's immense energy output could not be explained by chemical reactions alone. Instead, the source of the Sun's energy lies in the fusion of hydrogen nuclei into helium, a process that releases enormous amounts of energy. This discovery revolutionized our understanding of stars and provided a framework for studying the life cycles of stars of all sizes. The process of fusion not only powers the Sun but also creates the heavier elements that are essential for life and the formation of planets. The study of the Sun's fate has also led to important discoveries in other areas of astrophysics. For example, white dwarfs, once thought to be rare objects, are now known to be among the most common types of stars in the universe. These remnants of dead stars provide valuable clues about the end stages of stellar evolution and the ultimate fate of the cosmos. In addition, the study of planetary nebulae has revealed the rich complexity of the interactions between stars and their surrounding environments, shedding light on the processes that govern the recycling of material in the galaxy. As we contemplate the future of the Sun, we are also reminded of the fragility of life on Earth. The Sun's eventual transformation into a red giant will render our planet uninhabitable, forcing humanity to seek new homes elsewhere if we are to survive. While this event is still billions of years away, it serves as a stark reminder of the challenges that lie ahead for humanity as we navigate an ever-changing universe. The fate of the Sun underscores the importance of space exploration and the search for habitable exoplanets, as well as the need for technological advancements that could one day allow us to establish permanent settlements beyond our solar system. In the grand scheme of the universe, the Sun is just one star among billions in the Milky Way galaxy. Yet its fate, and the fate of the solar system, is deeply intertwined with the broader processes that govern the evolution of stars, planets, and galaxies. The death of the Sun will mark the end of one chapter in the cosmic story, but it will also pave the way for new beginnings. The material ejected from the dying Sun will contribute to the formation of future stars and planets, continuing the cycle of stellar evolution that has shaped the universe for billions of years. As we continue to explore the mysteries of the Sun and its eventual demise, we are reminded of the beauty and complexity of the universe. The Sun's journey from a main-sequence star to a white dwarf is just one example of the countless processes that govern the cosmos. Each new discovery, whether it involves the study of distant galaxies, the detection of exoplanets, or the observation of cosmic phenomena like black holes and neutron stars, adds to our understanding of the universe and our place within it. The Sun's fate, though billions of years in the future, offers a glimpse into the long-term evolution of the universe. It raises profound questions about the nature of time, the limits of human knowledge, and the ultimate destiny of the cosmos. As we look to the future, we can take comfort in the knowledge that, even as the Sun approaches the end of its life, the universe will continue to evolve, driven by the same forces that have shaped it since the beginning of time. The Sun's fate, as it transitions from a vibrant star to a cold, inert white dwarf, presents a staggering thought experiment when it comes to the passage of time. While human life and civilization seem boundless in the here and now, the cosmic timescale places us in a fleeting moment of the Sun's middle age. We are lucky to exist during a period in which the Sun is relatively stable, providing just the right conditions for life to flourish on Earth. This moment, however, is temporary, as the Sun's current phase of life is only a fraction of its total existence. As the Sun enters its red giant phase, swelling to a size that would engulf the orbits of the inner planets, the sheer magnitude of change that will occur in the solar system is almost beyond comprehension. During this stage, the energy radiated by the Sun will cause the remaining life on Earth to evaporate, boil, or burn away, long before the Sun reaches its final death throes. Even now, we can observe stars in various stages of their life cycles, and these observations give us insight into the Sun's future. Each red giant we study is a potential glimpse into our own distant destiny. Once the Sun exhausts its helium supply, gravity will ultimately win the battle, collapsing the outer layers and leaving behind a dense, degenerate core, the white dwarf. This remnant will contain roughly half of the Sun's original mass, but compressed into a volume similar to Earth's. While no longer undergoing fusion reactions, the white dwarf will still radiate residual heat from the tremendous energy stored within. Initially, this white dwarf will shine faintly, but over eons it will cool and fade, eventually becoming a cold, dark object known as a black dwarf, a theoretical state no white dwarf has yet reached given the universe's current age. The transition from white dwarf to black dwarf is not instantaneous. It is a slow, gradual cooling process that can take trillions of years, far longer than the universe has existed. In fact, no black dwarfs are thought to exist yet, because even the oldest known white dwarfs have not had enough time to cool to that state. As the white dwarf slowly cools, it will continue to radiate heat, but its light will grow dimmer and less visible. The final remnant of the Sun will be an object that no longer emits light or heat, essentially a cold cinder of what was once a vibrant star. What happens to the planets that remain in the outer solar system after the Sun becomes a white dwarf is a topic of scientific speculation. Without the Sun's energy to sustain them, the outer planets will experience extreme cooling, possibly freezing over completely. The gas giants like Jupiter and Saturn, composed mostly of hydrogen and helium, may continue to orbit the Sun, but their atmospheres will likely freeze, turning them into icy, inert objects. Moons that currently harbor potential for life, such as Europa or Titan, will also become frozen wastelands, their subsurface oceans turning into solid ice. One intriguing possibility for the future of the solar system involves the fate of the Kuiper Belt and the Oort cloud, regions that lie far beyond the orbit of Neptune. These distant regions of the solar system contain billions of icy bodies, including comets and dwarf planets like Pluto. As the Sun becomes a white dwarf, its diminished gravitational influence may allow some of these objects to drift away, escaping the solar system altogether. Others may remain in orbit, but they will be subjected to less gravitational pull and may take on more erratic paths. The eventual fate of the solar system may not be entirely sealed, as it is possible that interactions with other stars will disturb the delicate gravitational balance. Over billions or trillions of years, gravitational perturbations from passing stars or the galactic core may cause the remaining planets to be ejected from the solar system entirely. The solar system, once a bustling neighborhood of planets, asteroids, comets, and life, will be reduced to a cold, dark collection of drifting objects, scattered across the galaxy. The Sun's story is not just a tale of a single star's life and death, but a reflection of the universe's cyclical nature. The matter that composes the Sun, planets, and all living beings originated from the remnants of previous generations of stars. These stars, having exhausted their fuel, ended their lives in spectacular supernovae, scattering their material across space. Over time, this material coalesced into new stars and planets, continuing the cycle of stellar birth and death. The elements created in the Sun and other stars will eventually return to space, perhaps to form new stars and planets in the distant future. In the vast cosmic scale, the Sun is part of a much larger system of processes that shape galaxies and the universe as a whole. Its fate mirrors that of countless other stars that have already lived and died in the Milky Way. As we look out into the night sky and observe stars in various stages of their life cycles, we can see the Sun's future reflected in them. Some stars are just being born in vast stellar nurseries, while others are already nearing the end of their lives, on the verge of becoming white dwarfs or exploding as supernovae. The knowledge that our Sun is not unique in its fate also prompts philosophical reflection on the nature of existence. The impermanence of the Sun and the solar system forces us to confront the fact that all things, even stars, have a beginning and an end. This cosmic impermanence challenges our perception of time and our place in the universe. As humans, we are accustomed to thinking on much shorter timescales, but the Sun's life cycle reminds us that we are part of a much larger, ongoing process that spans billions of years. The end of the Sun's life will be one of the many events in the long history of the universe, which itself is evolving toward an unknown future. Some theories suggest that the universe will continue to expand indefinitely, with galaxies moving farther apart, stars burning out, and black holes eventually evaporating through Hawking radiation. This heat death scenario envisions a universe that will become cold, dark, and empty, with no sources of energy left to sustain any form of life or structure. In such a future, the remnants of stars like the Sun will be all that remains, drifting through the void. Other theories propose different outcomes, such as the possibility of a big crunch, where the universe's expansion eventually reverses, and all matter collapses back into a singularity. In this scenario, the remnants of stars and galaxies would be drawn back together, leading to a new cycle of cosmic rebirth. While these theories remain speculative, they highlight the profound mystery of the universe's ultimate fate, a question that has intrigued scientists and philosophers alike for centuries. As we continue to study the Sun and other stars, we gain not only a deeper understanding of stellar evolution but also a broader perspective on the universe's ongoing evolution. The Sun's fate as a white dwarf is just one part of the cosmic story, a story that includes the formation of galaxies, the birth and death of stars, and the potential for life to arise on planets orbiting distant stars. Each new discovery in astronomy adds another piece to this puzzle, helping us to better understand our place in the universe and the forces that shape it. The fate of the Sun, from its current main sequence phase to its eventual death as a white dwarf, is a reminder of the transient nature of all things in the universe. While the Sun will continue to shine for billions of years, its life, like all stars, will eventually come to an end. The transformation of the Sun into a red giant, and then a white dwarf will mark the end of an era for the solar system, but it will also be part of a larger process of cosmic evolution that has been ongoing since the beginning of time. The Sun's story is one of change, impermanence, and renewal, a story that reflects the ongoing cycle of life and death that governs the universe. As the Sun marches toward its inevitable fate as a white dwarf, the story of its evolution serves as a powerful metaphor for the life cycles of stars and celestial bodies throughout the universe. The vast timescales and physical processes at play stretch our imagination and challenge our understanding of the natural world. Yet, these processes have shaped not only the Sun and its eventual destiny, but also the development of our planet and the very existence of life itself. In its current phase, known as the main sequence, the Sun is steadily converting hydrogen into helium via nuclear fusion in its core. This process releases a tremendous amount of energy, which radiates outward and powers the light and heat we experience on Earth. The Sun's relatively stable output of energy has created conditions that are just right for liquid water to exist on our planet, a fundamental requirement for life as we know it. However, this period of stability is not eternal, and we live in what can be considered the Sun's golden age. Eventually, the Sun's core will run low on hydrogen, the fuel it has been burning for billions of years. When that happens, the core will contract, causing its temperature to rise dramatically. The outer layers of the Sun, in turn, will expand due to the increased energy flowing from the hotter core. This marks the beginning of the red giant phase, where the Sun will grow to hundreds of times its current size, potentially engulfing the inner planets, including Mercury, Venus, and possibly even Earth. The consequences of this expansion are stark. As the Sun swells, it will emit vastly more energy than it does today, and the intense heat will strip away the atmospheres of nearby planets, vaporize any remaining surface water, and render the Earth uninhabitable long before it is directly consumed. Life, as it has existed for millions of years, will cease, and the solar system will become a vastly different place. The Sun, now in its red giant phase, will dominate the sky, casting a red glow across what was once our solar neighborhood. But the red giant phase, for all its drama, is also temporary. Once the Sun's core reaches a critical temperature, the helium that has accumulated will ignite in a process known as helium fusion. This will create heavier elements, such as carbon and oxygen, as the Sun continues its transformation. During this process, the Sun will experience periods of instability, shedding much of its outer material into space. This material will form a stunning planetary nebula, a glowing shell of ionized gas that is one of the most beautiful sights observed in distant star systems. At the center of this nebula, the remaining core of the Sun will be exposed. This core, now composed mostly of carbon and oxygen, will no longer have enough pressure to sustain further fusion reactions. With no new source of energy, the core will begin to cool and shrink, leaving behind what is known as a white dwarf. A white dwarf is an incredibly dense object. It contains roughly half of the Sun's original mass, but compressed into a volume similar to that of Earth. The matter in a white dwarf is so densely packed that a single teaspoon of it would weigh several tons. The formation of the white dwarf marks the end of the Sun's active life. It will no longer undergo nuclear fusion, and instead, it will simply radiate away the heat that remains from its previous stages. Initially, a white dwarf can be quite hot, glowing with a faint blue or white light. Over billions of years, however, it will cool, fading into near invisibility. By this time, the solar system as we know it will be long gone. The outer planets, if they still exist, will be frozen, and any moons or smaller objects will have long since lost their ability to support life or maintain their atmospheres. Even though the Sun will have become a white dwarf, it will still be a significant object in terms of its gravitational influence. The white dwarf will continue to hold any remaining planets, moons, or asteroids in orbit, though their orbits may change slightly due to the loss of mass during the red giant phase. However, without the energy output of a living star, the remaining objects will be cold, barren, and lifeless. The solar system will resemble a cosmic graveyard, with the white dwarf at its center as a silent, fading reminder of the star that once sustained life. The cooling process of a white dwarf is incredibly slow. It is estimated that it will take trillions of years for a white dwarf to cool to the point where it no longer emits any significant heat or light. When this finally occurs, the white dwarf will become what is known as a black dwarf, a cold, dark object that is essentially inert. However, since the universe is only about 13.8 billion years old, no black dwarfs are thought to exist yet, as even the oldest known white dwarfs have not had enough time to cool completely. In the distant future, the Sun's transformation into a black dwarf will mark one of the final stages in the solar system's evolution. By this point, the galaxy itself may look very different from what we know today. Stars like the Sun are constantly forming and dying throughout the Milky Way, and over the course of billions of years, this cycle of stellar birth and death will continue. Eventually, the galaxy may become populated with more stellar remnants, white dwarfs, neutron stars, and black holes, than with active, shining stars. What becomes of the matter in the solar system, and the Sun itself, after this point is open to further speculation. Some scientists hypothesize that over extremely long timescales, the remnants of dead stars, including black dwarfs, may slowly disintegrate through processes such as proton decay or quantum tunneling. Others suggest that gravitational interactions with passing stars, or even collisions with other galaxies, may disrupt the orbits of planets and stellar remnants, scattering them across space. In a broader cosmic context, the Sun's death is part of the universe's ongoing evolution. As stars like the Sun die, they release material back into space, where it can contribute to the formation of new stars and planets. The heavier elements created in the Sun's core, such as carbon and oxygen, are essential building blocks for life. These elements, scattered across space by dying stars, may eventually become part of new solar systems, possibly giving rise to life elsewhere in the galaxy. Thus, while the Sun's fate may seem bleak from a human perspective, it is part of a much larger process that sustains the cosmos. The cycle of stellar death and rebirth ensures that the universe remains dynamic, constantly evolving and changing. The material created in stars like the Sun will continue to be recycled, contributing to the formation of new stars, planets, and perhaps even new forms of life. From a philosophical perspective, the Sun's eventual death forces us to confront our own impermanence. Just as the Sun will one day fade into obscurity, so too will all the achievements of humanity. Civilizations, monuments, and memories will eventually be lost to time as the forces of nature continue their inexorable march forward. Yet, in the face of this impermanence, the knowledge that we are part of the universe's larger story offers a form of solace. Our existence is intertwined with the fate of the stars, and while we may be temporary, we are also connected to the eternal processes that shape the cosmos. The Sun's life cycle, from its formation in a cloud of gas and dust to its eventual transformation into a white dwarf, is a testament to the beauty and complexity of the universe. It is a story of creation and destruction, of life and death, and of the intricate forces that govern the cosmos. As we continue to study the Sun and other stars, we gain not only a deeper understanding of the universe but also a greater appreciation for the fragile, transient nature of existence. In the grand scheme of the universe, the Sun is but one of countless stars, and its eventual death is one small event in the cosmic timeline. However, for us, the Sun is our star, the source of life on Earth, and its fate holds special significance. The Sun's story is a reminder of the interconnectedness of all things in the universe, from the smallest atoms to the largest galaxies. It is a story of change, of evolution, and of the ongoing cycle that defines the cosmos. The fate of the Sun, as it transitions from a main sequence star to a white dwarf, is not only a story about our local star, but also a key chapter in the cosmic life cycle of all stars of similar size. Throughout the universe, billions of stars are undergoing similar processes, and the remnants of these stars have shaped galaxies, created planets, and even contributed to the development of life. The Sun, being an average-sized star, follows a well-understood path of stellar evolution that informs us about the past, present, and future of stars and planetary systems everywhere. When we look at other stars in the universe, we are often seeing them at various stages of their life cycle. Some are in their infancy, forming from clouds of gas and dust, while others are in the midst of their main sequence, just like the Sun is today. Some stars, however, are nearing the end of their lives, expanding into red giants, shedding their outer layers, or collapsing into dense remnants like white dwarfs, neutron stars, or black holes. These various stages of stellar evolution are all tied to the mass of the star, and the Sun's journey is typical of a low to intermediate mass star. Larger stars, for example, have much more dramatic life cycles than stars like the Sun. These massive stars burn through their nuclear fuel at a far greater rate, leading to a much shorter lifespan. When they run out of fuel, they end their lives in spectacular supernova explosions, which can outshine entire galaxies for brief periods of time. The core left behind may collapse into a neutron star or, if massive enough, a black hole. The remnants of these explosive deaths also contribute to the cosmic enrichment of heavier elements, just as the Sun will eventually contribute carbon and oxygen to the surrounding space as it becomes a white dwarf. However, unlike the violent end of massive stars, the Sun's death will be much quieter and more gradual. The Sun's red giant phase will certainly be dramatic, especially for any remaining life forms or planets in its vicinity, but it will not end in a supernova. Instead, the shedding of its outer layers into a planetary nebula and the formation of a white dwarf will occur over tens of thousands of years, a slow and relatively peaceful process compared to the cataclysmic demise of more massive stars. This gentler death is the hallmark of stars like the Sun, which lack the mass to trigger the extreme gravitational collapse needed to ignite a supernova. The end of the Sun's fusion process will also mark the end of its ability to support planets with energy. During the red giant phase, the intense heat and radiation will strip away the atmospheres of any remaining planets in the inner solar system. Earth's atmosphere will boil away, and the oceans will evaporate long before the planet itself is potentially consumed by the Sun's expanding outer layers. Even the more distant planets, like Mars and Jupiter, will experience significant changes. Mars, which currently sits in the cold, arid outer regions of the solar system, may warm up temporarily as the Sun's energy output increases. But any potential for life or habitability will be short-lived, as the red giant phase is unstable and unpredictable. As the outer layers of the Sun drift away to form the glowing shell of a planetary nebula, the remaining core will shrink and become extremely dense, forming the white dwarf. White dwarfs are fascinating objects in their own right, as they represent the final, stable state of stellar matter for stars like the Sun. Though small and no longer generating energy, white dwarfs are incredibly hot when they first form, and they glow with residual heat for billions of years. These stellar remnants provide valuable insights into the properties of degenerate matter, where electrons are packed so tightly that quantum mechanical effects dominate their behavior. Interestingly, white dwarfs are supported against further gravitational collapse by electron degeneracy pressure, a quantum mechanical phenomenon that arises because electrons, as fermions, cannot occupy the same quantum state. This creates a powerful force that resists further compression, allowing the white dwarf to maintain its structure despite its incredible density. Over time, however, the white dwarf will gradually cool and dim, becoming fainter and fainter as it radiates away its remaining heat. While no white dwarfs have yet had time to cool to the point of becoming black dwarfs, this is the final stage in their evolution. The cooling process for a white dwarf takes billions, if not trillions, of years, and by the time they reach this final stage, they will have become virtually undetectable. Black dwarfs, once they form, will be dark, cold, and inert, effectively invisible remnants of stars that once shone brightly in the night sky. The slow fade into darkness of these stellar remnants is a humbling reminder of the impermanence of even the brightest objects in the cosmos. As the sun transitions into a white dwarf, the material it has expelled into space will not go to waste. The gas and dust that form the planetary nebula will eventually disperse into the interstellar medium, where it will mix with other material from dying stars. Over time, this enriched material, now containing elements like carbon, oxygen, and nitrogen, will become part of the raw material for new stars and planets. The cycle of stellar birth and death is one of the most fundamental processes in the universe, ensuring that the cosmos remains dynamic and ever-changing. The Sun's contribution to this process will be relatively modest compared to more massive stars, but it will nonetheless play a role in the ongoing evolution of the galaxy. The carbon and oxygen produced in the Sun's core will be crucial for the formation of new planets and potentially new forms of life in the distant future. In this way, the Sun's death will contribute to the continuation of life elsewhere in the universe, even as the solar system itself fades into obscurity. In a broader sense, the fate of the Sun serves as a poignant reminder of the finite nature of all things in the universe. Stars are born, they shine for billions of years, and then they die. Even the most massive stars, with their short, brilliant lives, must eventually succumb to the inexorable forces of gravity and entropy. Yet, within this cycle of creation and destruction, new possibilities arise. The elements forged in the hearts of stars become the building blocks of planets, life, and the complex structures we see in the universe today. As we reflect on the fate of the Sun, it is important to remember that the story of our star is not unique. Throughout the universe, stars are living out their own life cycles, many of them following a similar path to that of the Sun. Some are just beginning their journey, fusing hydrogen in their cores and providing warmth and light to any surrounding planets. Others are nearing the end of their lives, expanding into red giants or exploding in supernovae. And still others have already become white dwarfs, neutron stars, or black holes, silently marking the end of their stellar lifetimes. The study of stellar evolution, including the fate of the Sun, allows us to understand the larger forces at work in the universe. It gives us a glimpse into the future of our solar system and the distant fate that awaits not only the Sun but also the Earth and its fellow planets. While the timescales involved are far beyond human experience, the processes that drive the evolution of stars are universal, affecting galaxies, star systems, and the very fabric of the cosmos. In the far distant future, long after the Sun has become a white dwarf and cooled into a black dwarf, the universe itself will continue to evolve. Galaxies will merge, stars will continue to be born and die, and the expansion of the universe will stretch space-time to its limits. The Sun's life and death will be but a small chapter in the vast story of the cosmos, a reminder that even the most familiar and constant objects in our lives are part of a much larger, ever-changing universe. The journey of the Sun from its birth in a stellar nursery to its eventual death as a white dwarf is one of the most profound stories in the universe. It is a story of energy, transformation, and the relentless passage of time. As we continue to study the Sun and other stars, we gain a deeper appreciation for the forces that shape the universe and our place within it. The fate of the Sun is not only a scientific curiosity but also a philosophical reflection on the impermanence of all things, reminding us that, in the grand scheme of the cosmos, everything is connected, and nothing lasts forever. As the Sun continues its inexorable journey toward becoming a white dwarf, we must also consider the fate of the solar system itself. While the Sun's transition into a red giant and eventual collapse into a white dwarf will take place over billions of years, these events will have profound effects on the planets, moons, and other objects orbiting the Sun. The planets in particular, including Earth, will face monumental changes during the Sun's red giant phase. When the Sun begins to swell into a red giant, its outer layers will expand significantly, potentially enveloping the orbits of the inner planets, including Mercury, Venus, and possibly even Earth. This swelling of the Sun will cause temperatures in the inner solar system to rise dramatically, leading to the destruction of planetary atmospheres and the boiling away of oceans. Earth, once teeming with life, will be transformed into a barren, lifeless rock, its surface scorched by the intense heat of the dying Sun. However, before the Earth is completely consumed by the Sun's outer layers, its fate could be more complicated. As the Sun loses mass during its red giant phase, the gravitational pull it exerts on the planets will weaken. This reduction in gravity could cause the orbits of the planets to expand slightly, moving them farther from the Sun. In some scenarios, this shift in orbit could allow Earth to avoid being engulfed by the Sun's outer envelope, though it would still be rendered uninhabitable by the extreme heat and loss of its atmosphere. For the outer planets, such as Jupiter, Saturn, Uranus, and Neptune, the red giant phase will have less dramatic effects. These gas giants are located far enough from the Sun that they will not be directly impacted by the expanding star. However, their atmospheres will likely experience changes as the energy output of the Sun fluctuates during the red giant phase. Additionally, the loss of mass from the Sun could cause these outer planets to drift farther from the star, altering the structure of the solar system. The moons of these gas giants, which include some of the most intriguing candidates for life in the solar system, such as Europa and Titan, could also experience significant changes during this time. As the outer planets move farther from the Sun, the temperatures on these moons could drop, making the environments even more inhospitable. However, for moons like Europa, which may have subsurface oceans beneath their icy crusts, the increased distance from the Sun might have little effect on their potential habitability, as their internal heat comes from tidal forces rather than sunlight. As the Sun loses more of its mass during the red giant phase, the asteroid belt, Kuiper belt, and even the Oort cloud, regions of the solar system filled with rocky and icy debris, could be affected as well. Objects in these regions may experience changes in their orbits, leading to a more chaotic distribution of material. Some of this debris could be ejected from the solar system entirely, while other objects could collide or be pulled toward the dying Sun. As the Sun sheds its outer layers to form a planetary nebula, this material will mix with the surrounding interstellar medium, enriching the galaxy with heavier elements like carbon and oxygen. These elements, which were forged in the Sun's core during its lifetime, will go on to become part of new stars, planets, and potentially new life forms elsewhere in the galaxy. In this way, the death of the Sun will contribute to the ongoing cycle of stellar evolution that drives the formation of new solar systems throughout the universe. The planetary nebula that forms around the Sun during this final phase of its life will be a beautiful and haunting sight. These glowing shells of gas and dust are often visible to astronomers with telescopes, and they are some of the most stunning objects in the night sky. Each planetary nebula is unique, with its own intricate patterns and colors, shaped by the interactions between the dying star and the surrounding material. For a few tens of thousands of years, the Sun's planetary nebula will be visible, a bright beacon in the darkening sky, before it gradually fades away. Eventually, the only thing that will remain of the Sun is the white dwarf at its core. This white dwarf will be an incredibly dense object, with a mass similar to that of the Sun but compressed into a volume roughly the size of Earth. Despite its small size, the white dwarf will still exert a strong gravitational pull, and any remaining planets, moons, or debris in the solar system will continue to orbit around it. White dwarfs, although no longer undergoing nuclear fusion, can still emit light and heat for billions of years as they gradually cool. Over time, however, the white dwarf will lose its residual heat and grow colder and dimmer, eventually becoming a black dwarf. Black dwarfs are hypothetical objects, as the universe is not yet old enough for any white dwarfs to have cooled to this point, but they represent the final stage in the life of low to intermediate mass stars like the Sun. Once the Sun becomes a black dwarf, it will be a cold, dark, and inert object, barely distinguishable from the surrounding space. The solar system, too, will be a cold and desolate place, with no heat or light to sustain life. The planets, if they still exist, will be frozen and lifeless, drifting through space around the dead remnants of their once vibrant star. This final fate of the Sun and the solar system is part of the broader story of the universe's evolution. Over time, as more and more stars exhaust their nuclear fuel and die, the universe will grow darker and colder. The process of star formation, which has driven the evolution of galaxies for billions of years, will eventually slow down and stop as the available gas and dust are used up. In the distant future, the universe may enter a state known as heat death, in which all energy has been evenly distributed and no new stars can form. The concept of heat death is one of the possible end scenarios for the universe, and it paints a bleak picture of the distant future. In this scenario, all stars will have either burned out or collapsed into black holes, and the universe will be filled with dark, dead objects, black dwarfs, neutron stars, and black holes. Over unimaginable timescales, even black holes may eventually evaporate through a process known as Hawking radiation, leaving behind only faint traces of radiation in an empty, cold universe. While this distant future may seem bleak, it is important to remember that the universe is constantly evolving, and the timescales involved are far beyond human comprehension. The death of the Sun, and the eventual fate of the universe, are billions or even trillions of years away. In the meantime, the universe remains a vibrant and dynamic place, filled with the birth, life, and death of stars, the formation of new planets, and the possibility of life arising elsewhere in the cosmos. The Sun's fate as a white dwarf is just one chapter in the larger story of the universe's evolution. As we continue to study stars and their life cycles, we gain a deeper understanding of the forces that shape the cosmos and our place within it. The study of stellar evolution also reminds us of the interconnectedness of all things in the universe, how the elements forged in stars become part of planets and life, and how the death of one star can contribute to the birth of new stars and solar systems. In a sense, the Sun's journey from a main sequence star to a white dwarf is a microcosm of the universe's broader evolution. Just as the Sun will eventually exhaust its fuel and die, so too will the universe itself one day reach a state of equilibrium in which no new energy can be produced. Yet, within this cycle of creation and destruction, there is beauty and wonder. As new stars are born, planets form, and life emerges. The fate of the Sun is a reminder that everything in the universe is temporary, but also that everything is connected. The atoms that make up our bodies were forged in the hearts of stars like the Sun, and the energy that sustains life on Earth comes from the Sun's nuclear fusion. When the Sun eventually dies, its elements will return to the cosmos, becoming part of new stars, planets, and possibly even new forms of life. As we look to the future, we can take comfort in the knowledge that the universe is constantly changing and evolving. The death of the Sun, while inevitable, is just one part of the larger cycle of stellar evolution that has been shaping the universe for billions of years. And while the Sun's fate as a white dwarf may seem distant and abstract, it is a reminder of the impermanence of all things in the vast, interconnected web of processes that govern the cosmos. The eventual transformation of the Sun into a white dwarf also prompts us to reflect on humanity's place in the cosmos and the potential future of life in the solar system. As the Sun ages and begins to change, the conditions that have made Earth a haven for life will deteriorate. This presents a profound challenge for the survival of humanity and other life forms on Earth. Given that the timeline for the Sun's death is measured in billions of years, humanity, should it survive that long, will eventually need to confront the question of how to adapt to these changing conditions. One possibility is that humanity, or its descendants, will need to find a way to leave Earth and establish colonies elsewhere in the solar system or even in other star systems. The search for habitable planets beyond our solar system has already begun, with astronomers discovering thousands of exoplanets orbiting distant stars. Some of these exoplanets lie in the habitable zone of their stars, where conditions could be suitable for liquid water and potentially life. In the distant future, humans may look to these planets as potential new homes when Earth becomes uninhabitable. However, the challenge of interstellar travel is immense. The distances between stars are vast, and even the closest star system, Alpha Centauri, is over 4 light-years away, a distance that would take tens of thousands of years to traverse using current technology. To overcome this challenge, future generations would need to develop new technologies that allow for faster-than-light travel or methods of sustaining life during long journeys through space, such as generation ships or cryogenic suspension. Alternatively, humanity might focus on creating artificial habitats within the solar system itself. These habitats could take the form of space stations or colonies on other planets or moons. Mars, for example, is often considered a candidate for colonization due to its relatively close proximity to Earth and its potential for supporting human life with the right technological advancements. Efforts are already underway to explore the possibility of establishing a human presence on Mars, with organizations like NASA and private companies like SpaceX working on plans for crewed missions to the Red Planet. In addition to Mars, the moons of the outer planets, such as Europa, Titan, and Enceladus, offer intriguing possibilities for human exploration and colonization. These moons may harbor subsurface oceans beneath their icy surfaces, and scientists are interested in studying them not only for the potential of finding life but also for the possibility of establishing bases or outposts. While these environments are harsh and challenging, the advancement of technology could one day make it feasible for humans to live and thrive in such extreme conditions. The future of humanity in the face of the sun's eventual demise raises deep philosophical and ethical questions as well. As we contemplate the survival of our species, we must also consider the moral implications of altering or abandoning our home planet. The drive to explore and colonize other worlds is often motivated by the desire to ensure the long-term survival of humanity, but it also forces us to confront the impact we have on the environments we inhabit. If we were to establish colonies on other planets, we would need to consider how to balance the needs of human survival with the preservation of the natural ecosystems that may exist on those worlds. Moreover, the future of life on Earth itself, beyond humanity, must also be considered. As the sun evolves, the extinction of many species is inevitable, but life on Earth has proven to be remarkably resilient over billions of years. Even in the face of extreme changes, it is possible that certain forms of life, particularly extremophiles, organisms that thrive in extreme environments, could persist for much longer than humans. The question then becomes whether it is possible, or even ethical to attempt to preserve life on Earth in the face of the sun's changes, or whether our focus should solely be on human survival. Another intriguing possibility is that future civilizations could develop technologies that allow them to directly intervene in the fate of the sun. While this idea may seem far-fetched by today's standards, it falls within the realm of speculative science and long-term human advancement. Some scientists and futurists have proposed the idea of stellar engineering, the manipulation of stars to alter their life cycles. This could theoretically involve processes such as injecting additional fuel into the sun's core to extend its life or artificially controlling the fusion processes that occur within it. One such concept is the Dyson sphere, a hypothetical megastructure that could be built around a star to capture its energy. While this concept is often associated with harnessing a star's power for energy, it also raises the possibility of more advanced civilizations having the capability to regulate or stabilize a star's fusion reactions. If humanity were to reach this level of technological sophistication, it might be possible to extend the sun's life or at least control the pace of its evolution, delaying its transition into a red giant and allowing life on Earth to continue for much longer than currently predicted. In considering the future of the sun and its impact on humanity, we must also think about our legacy as a species. If humanity is able to survive beyond the lifespan of the sun, what kind of civilization will we become? Will we remain confined to our solar system, or will we spread across the galaxy, exploring and colonizing new worlds? Will we be able to preserve the knowledge we have accumulated over millennia, or will we face the risk of collapse and extinction? These questions are speculative but important as we look toward the future of our species and our place in the universe. The story of the sun's life and death is a reminder that nothing in the cosmos is permanent, and that we must constantly adapt and evolve to survive. It also challenges us to think creatively about the possibilities that lie ahead, both in terms of the technologies we may develop and the ethical decisions we will need to make. The fate of the sun, from its current stable state as a main sequence star to its future as a white dwarf, is part of the grand narrative of cosmic evolution. Stars like the Sun are the engines of the universe, driving the creation of planets, elements, and life itself. Their life cycles are intricately connected to the larger processes that shape galaxies and the universe as a whole. While the Sun's eventual death may seem like a distant and abstract event, it is a reminder of the transient nature of all things and the interconnectedness of the cosmos. As we continue to explore the universe and uncover its mysteries, we will undoubtedly learn more about the life cycles of stars and the fate of solar systems like our own. Advances in astronomy, astrophysics, and space exploration are constantly expanding our understanding of the universe and our place within it. With each new discovery, we gain a deeper appreciation for the complexity and beauty of the cosmos, and we are reminded of the profound impact that celestial events like the death of the Sun can have on life. The story of the Sun's life and death is not just a story of destruction, it is also a story of creation, transformation, and renewal. The elements forged in the Sun's core will become part of new stars, new planets, and potentially new life forms, continuing the cycle of stellar evolution that has been shaping the universe for billions of years. Humanity, too, is part of this cosmic story, and our fate is intertwined with the fate of the Sun and the broader forces that govern the universe. While we may not be able to change the ultimate destiny of the Sun, we have the opportunity to shape our own future as a species. Through scientific exploration, technological advancement, and thoughtful consideration of our place in the universe, we can ensure that humanity continues to thrive, even as the Sun and the solar system evolve. The journey ahead is filled with challenges and uncertainties, but it is also filled with possibilities for discovery, growth, and adaptation. In contemplating the fate of the Sun, we are reminded of the vastness of the universe and the complexity of the forces that govern it. The Sun is just one of billions of stars in our galaxy, and our galaxy is just one of billions in the universe. Yet, despite the scale of the cosmos, we are connected to it in fundamental ways, and our survival depends on our understanding of the processes that shape it. The story of the Sun's life and death is not just a scientific one, it is also a deeply human one, filled with questions about our future, our legacy, and our place in the cosmos. As we explore the fate of the Sun and what it means for humanity, it is essential to reflect on the profound influence that our star has had on life on Earth. The Sun is not merely a source of light and warmth, it is the cornerstone of our planet's ecosystems and climate systems. Photosynthesis, the process by which plants convert sunlight into energy, is the foundation of nearly all food chains on Earth. Without the Sun, life as we know it would not exist, highlighting its central role in sustaining the delicate balance of life on our planet. As the Sun transitions through its life stages, its influence on Earth will become increasingly pronounced. During its main sequence phase, the Sun has provided a stable environment conducive to life. However, as it evolves into a red giant, the consequences for Earth will be severe. The increase in solar luminosity will lead to the heating of the planet's surface, causing oceans to evaporate, and rendering the planet inhospitable to most forms of life. This scenario forces us to consider not just our own survival, but the survival of countless species that share this planet with us. The extinction of species is an inevitable outcome of the Sun's evolution. Throughout Earth's history, mass extinction events have occurred as a result of natural processes, such as asteroid impacts or volcanic activity, but the gradual transformation of the Sun poses a unique and long-term threat. The extinction of familiar species and the emergence of new ones will characterize this period. This is part of a larger cycle of evolution, where life adapts to changing conditions, but it poses a significant moral question. As stewards of our planet, what responsibility do we have to protect and preserve the diverse forms of life that exist today? Moreover, the Sun's changes may also inspire new philosophical and ethical frameworks around our existence and our responsibilities. With the understanding that our star is finite, we are encouraged to appreciate and protect our environment more fervently. The beauty of the Earth, its intricate ecosystems, and its breathtaking landscapes are fleeting in the cosmic timescale. The realization that life is precious, and that we are inextricably linked to our Sun, can instill a deeper sense of purpose in our stewardship of the Earth. The inevitability of the sun's transformation reminds us of the transient nature of our existence. This perspective can lead to a greater appreciation of life and the relationships we build during our time on this planet. Embracing this transient beauty may encourage us to forge connections not only with each other but also with the natural world around us. It prompts us to seek harmony with the environment and to advocate for sustainable practices that preserve the planet for future generations. As we contemplate the fate of the sun, we must also recognize the importance of scientific literacy and public engagement in the field of astronomy. Understanding the cosmos, the life cycles of stars, and the potential futures that await us is not just the domain of scientists and scholars. It is a collective endeavor that requires the participation of everyone. As we face global challenges such as climate change, resource depletion, and technological advancements, fostering a culture of inquiry and curiosity about the universe can help us make informed decisions about our future. The study of the sun and its eventual demise serves as a reminder of the need for interdisciplinary approaches to tackling the problems we face today. By integrating knowledge from astronomy, environmental science, ethics, and philosophy, we can create a more comprehensive understanding of our place in the universe and how to navigate the challenges that lie ahead. This holistic perspective can empower us to take meaningful action to protect the planet and prepare for an uncertain future. The sun's journey to becoming a white dwarf is not just a tale of astrophysics. It is a narrative filled with implications for our understanding of time, existence, and evolution. It encapsulates the story of all stars, which, like us, have finite lifespans and play a crucial role in the cosmic tapestry. Our star is a reminder of the intricate connections that bind us to the universe. As we gaze into the night sky, we are not just observing distant suns. We are witnessing the legacy of stellar evolution and the cosmic cycle of birth and death. In closing, the fate of the sun raises profound questions about our own existence and the legacy we leave behind. As it transitions from a vibrant main sequence star to a silent white dwarf, it will serve as a symbol of both the fragility and resilience of life. Humanity's journey into the future will be shaped by the lessons learned from our star's life cycle. We must harness our knowledge, creativity, and collective spirit to ensure that the story of life on Earth continues, transcending the limits of time and the constraints of our solar system. The evolution of the sun reminds us that change is a constant in the universe. It urges us to embrace the unknown, to seek knowledge, and to take responsibility for the planet we inhabit. In doing so, we honor the legacy of our star and the vibrant life it has sustained for billions of years. As we move forward, we must carry with us the wisdom gleaned from the past, the hope for the future, and the understanding that, like the sun, we are all part of a much grander cosmic narrative. As we continue our exploration of the sun's fate, we can delve deeper into the science of stellar evolution, particularly how our understanding of this process has advanced over time. The journey of the sun from a main sequence star to a white dwarf is not just a tale of cosmic events. It is also a reflection of humanity's growing curiosity and understanding of the universe. Early astronomers gazed at the night sky, forming theories about the stars without the benefit of modern technology. Today, we possess advanced telescopes, satellites, and computer simulations that allow us to model the life cycles of stars with remarkable precision. The main sequence phase of the sun, which lasts about 10 billion years, is characterized by a stable balance between the gravitational forces trying to collapse the star inward and the outward pressure generated by nuclear fusion in its core. During this phase, the sun fuses hydrogen into helium, producing the energy that powers our solar system. This nuclear fusion process is a fundamental aspect of stellar physics and plays a crucial role in determining a star's lifetime and ultimate fate. As the sun exhausts its hydrogen fuel, it will undergo significant changes. When the hydrogen in the core is depleted, the fusion process will slow down, causing the core to contract under the force of gravity. This contraction raises the temperature and pressure in the core, eventually leading to the onset of helium fusion. The outer layers of the sun will respond to the increased energy production in the core by expanding, resulting in the sun becoming a red giant. This expansion is not just a dramatic visual change. It signifies a critical transformation in the star's life cycle. During this red giant phase, the outer envelope of the Sun will swell, potentially engulfing the inner planets, including Mercury and Venus, and possibly even Earth. The process is marked by a profound alteration in the dynamics of the solar system. The gravitational influences will shift, and the orbits of remaining planets could be affected, leading to an unstable celestial environment. The idea of Earth being consumed by the Sun is both frightening and fascinating, serving as a poignant reminder of the impermanence of our planetary home. Following the red giant phase, the Sun will shed its outer layers, creating a stunning nebula, a glowing shell of gas and dust that is a byproduct of stellar evolution. This phase is characterized by the loss of mass from the star, which releases a significant amount of material back into the interstellar medium. This material contributes to the formation of new stars, planets, and possibly even life forms, continuing the cycle of cosmic evolution. The nebula will eventually disperse, and what remains of the Sun will be a hot core, the white dwarf. A white dwarf is an incredibly dense remnant of a star that no longer undergoes fusion reactions. It is primarily composed of carbon and oxygen, and has a mass comparable to that of the Sun but a volume similar to that of Earth. The density of a white dwarf is staggering. A sugar cube-sized amount of material from one would weigh as much as several tons on Earth. The white dwarf will gradually cool over billions of years, eventually fading into a cold, dark remnant known as a black dwarf. However, this final stage is hypothetical, as the universe is not yet old enough for any white dwarfs to have cooled to this state. The journey of the Sun from its vibrant existence to a cold white dwarf encapsulates the broader processes of stellar evolution that govern the life cycle of stars throughout the universe. Every star, regardless of its size and mass, follows a similar evolutionary path. Massive stars, for instance, undergo more dramatic transformations, ultimately leading to supernova explosions, leaving behind neutron stars or black holes. In contrast, smaller stars like the Sun take a more subdued route, transitioning from red giants to white dwarfs. This stellar life cycle has profound implications for the universe at large. Stars are the primary factories of heavy elements. During their lives, they synthesize elements such as carbon, nitrogen, and oxygen, which are essential for life. When stars die, they release these elements into the cosmos, seeding new star systems with the building blocks of life. The birth and death of stars contribute to the dynamic, ever-evolving structure of the universe, highlighting the interconnectedness of all cosmic phenomena. Moreover, understanding the life cycle of stars offers crucial insights into the future of our solar system and the fate of humanity. As we consider the long-term implications of the Sun's evolution, we must also contemplate our place in the universe. Our understanding of stellar processes not only deepens our appreciation for the cosmos but also shapes our vision for the future of space exploration and colonization. As the Sun approaches the end of its life, humanity may find itself at a crossroads. While the Sun's transition into a red giant is billions of years away, it raises the question of long-term survival. Are we, as a species, prepared for the eventual challenges posed by the Sun's evolution? The concept of space colonization is increasingly gaining traction as scientists and visionaries contemplate the possibilities of establishing human habitats beyond Earth. Mars, with its similarities to our planet, is often considered a candidate for future colonization, but it poses its own set of challenges. In contemplating our future in space, we must consider not only the technical challenges of space travel and settlement, but also the ethical implications of becoming an interplanetary species. What responsibilities do we have to protect and preserve extraterrestrial environments? How do we ensure that the mistakes we have made on Earth are not repeated elsewhere in the solar system? These questions require careful consideration as we move towards a future where humanity may live among the stars. Furthermore, the advancement of technology plays a crucial role in our ability to understand and adapt to the Sun's changes. Innovations in astronomy and space exploration provide us with tools to study solar activity, solar flares, and coronal mass ejections, which can impact communication systems and satellites on Earth. Understanding these phenomena helps us develop strategies to mitigate their effects and safeguard our technological infrastructure. The fate of the sun serves as a profound reminder of the impermanence of our cosmic surroundings. The journey from a vibrant main-sequence star to a silent white dwarf encapsulates the delicate balance of cosmic forces that govern the universe. As we gaze at the stars, we are reminded of our connection to the cosmos and the fleeting nature of our existence. The sun, our life-giving star, will eventually face its own demise, prompting us to reflect on our role in the universe and the legacy we will leave behind. As we contemplate the long-term implications of stellar evolution, we are invited to engage with the mysteries of the cosmos. The story of the sun and its eventual transformation speaks to the broader narrative of life, death, and rebirth in the universe. It is a reminder that, while we may be mere specks in the vastness of space, our understanding and appreciation of the cosmos can empower us to forge a future that honors the interconnectedness of all life. Thus, the fate of the sun is not just a tale of astrophysics. It is an invitation to reflect on our place in the universe, to appreciate the beauty of life on Earth, and to embrace the unknown with curiosity and wonder. As we continue to explore the mysteries of space, we must remember that our journey is intertwined with the fate of the stars, and it is this connection that ultimately defines our existence. As we journey deeper into the complexities surrounding the fate of the sun, it becomes essential to explore not just the astrophysical processes, but also the implications for humanity and the broader cosmos. The sun's evolution is a lens through which we can view the life cycle of stars, the interconnectivity of cosmic events, and the fate of planetary systems. Understanding the eventual transformation of our sun into a white dwarf extends beyond mere scientific curiosity. It influences how we view our existence and our future as a species. At the heart of this exploration lies the concept of time. The sun has already existed for about 4.6 billion years, a testament to the timescale on which stellar evolution operates. For most of its life, it has remained a stable, life-sustaining force in our solar system, allowing the Earth to flourish with life. However, this stability is not eternal. The transition from main sequence to red giant will occur long after humanity, as we know it, has evolved, changed, or potentially vanished. This thought provokes deeper philosophical inquiries. How should we live in light of our sun's impending fate? What legacies do we wish to leave behind as custodians of life on Earth? The knowledge of the sun's life cycle urges humanity to consider our longevity and adaptability. As the sun progresses through its stages, will we have developed the necessary technology and wisdom to adapt to changing conditions? The idea of space colonization is not merely science fiction, it is a potential reality we must prepare for. Plans for missions to Mars and beyond are already in the works, emphasizing the importance of becoming a multiplanetary species. However, such an endeavor requires immense resources, collaboration, and innovation. We must focus on developing sustainable technologies that allow us to thrive in environments different from our own. Additionally, the sun's activity plays a significant role in the dynamics of space weather. Solar flares and coronal mass ejections can disrupt communications and power grids on Earth, showcasing the importance of studying solar physics. Understanding the sun's behavior can help us mitigate these impacts, ensuring our technological advancements are protected. As we become more reliant on technology, the need for this understanding will only grow. In considering the sun's fate, we must also think about the solar system's architecture. As the sun enters its red giant phase, its gravitational influence will change, leading to a reconfiguration of the solar system. The outer planets, Jupiter, Saturn, Uranus, and Neptune, will likely be less affected than the inner planets, but the entire solar system will feel the effects of this transformation. The gravitational dance between celestial bodies is a delicate balance, and any significant changes can have far-reaching consequences. Understanding these dynamics can help us appreciate the complexity of celestial mechanics and the interconnectedness of planetary systems. The implications of the sun's transformation are not limited to physical changes. They also raise questions about humanity's philosophical and ethical responsibilities. If we envision a future where humanity has the technology to escape a dying Earth, what ethical obligations do we have to ensure the preservation of life? Are we to simply abandon our home planet, or do we have a duty to preserve its environment and ecosystems? These questions challenge us to consider our role as stewards of the Earth and how we approach the challenges posed by our sun's evolution. Moreover, the fate of the sun serves as a humbling reminder of the transient nature of existence. Just as the sun will eventually exhaust its nuclear fuel, all living beings must face the inevitability of death. This acknowledgement can foster a deeper appreciation for life and the universe. The limited time we have allows us to contemplate our actions, relationships, and the impact we leave behind. It encourages us to seek understanding, connection, and purpose in our lives while we have the opportunity. As we look toward the future, we are compelled to recognize that while the sun's life is predictable within the framework of stellar evolution, the future of humanity is uncertain. The advancements we make in science and technology can pave the way for a more sustainable existence, but they also present challenges that require careful navigation. The potential for colonizing other planets poses questions about the ethics of exploration, resource utilization, and environmental conservation. As we contemplate our cosmic future, we must weigh the benefits of exploration against the responsibility to protect the natural beauty of the planets we may inhabit. In contemplating the future of the sun and humanity, we also engage with the profound concept of legacy. The legacy of a star extends far beyond its physical presence. The elements forged in its core during its lifetime are recycled into new stars, planets, and potentially, life. This cosmic recycling emphasizes the idea that we are made of stardust, a poetic reminder of our connection to the universe. Understanding the cyclical nature of existence invites us to reflect on what we wish to contribute to the cosmos during our brief time. While the sun's ultimate fate may seem distant, the changes it will undergo will significantly shape the conditions of our solar system. Scientists and astronomers continue to study other stars at various stages of their life cycles, seeking to understand the broader implications of stellar evolution. Observations of distant stars, particularly those similar to our sun, provide valuable insights into our own star's future. By studying these celestial phenomena, we enhance our understanding of the intricate processes that govern the universe. The fascination with the sun's fate extends beyond scientific inquiry. It resonates deeply with humanity's innate curiosity about the cosmos. As we contemplate the destiny of our star, we are reminded of the cosmic forces at play and our place within this vast expanse. The journey from main sequence to white dwarf encapsulates not only the life of a star but also the essence of existence itself, a blend of creation, transformation, and eventual dissolution. This reflection inspires awe and wonder, pushing us to explore the cosmos further. Missions to Mars, the exploration of asteroids, and the study of exoplanets fuel our desire to understand the universe and our potential role within it. Each new discovery serves as a reminder of our insignificance in the grand scheme of the cosmos while simultaneously igniting a sense of responsibility to seek knowledge and understanding. Ultimately, the fate of the sun encourages us to contemplate the future of our species. The legacy we leave behind, the values we uphold, and the connections we foster will shape the narrative of humanity as we venture into the unknown. As we consider the changes that await our solar system, we must also reflect on our capacity for innovation, resilience, and collaboration. The challenges posed by the sun's evolution may seem daunting, but they also present opportunities for growth and unity. In closing, the fate of the sun, a magnificent star that has graced our sky for billions of years, serves as a poignant reminder of the impermanence of existence. It invites us to embrace the mysteries of the cosmos, to question our role in the universe, and to strive for a future that honors our shared legacy. As we continue to seek answers to the mysteries of space, may we carry with us the knowledge that we are all interconnected, bound by the stardust that flows through our veins. The story of the sun's journey from a vibrant main-sequence star to a distant white dwarf is not merely an account of stellar evolution. It is an invitation to explore the depths of our existence, to reflect on our place in the universe, and to celebrate the fleeting beauty of life. In every heartbeat, every breath, and every moment, we are reminded of the cosmic dance that surrounds us, urging us to embrace the wonder of the universe and the infinite possibilities that lie ahead. As we delve deeper into the fate of our sun, it's essential to consider not only the scientific aspects but also the potential repercussions for life on Earth and the broader universe. The transition from a main sequence star to a white dwarf is an awe-inspiring journey marked by immense changes, and its implications extend far beyond the realm of astrophysics. First, let's explore the concept of habitability as it relates to the Sun's evolution. Currently, Earth exists within the Goldilocks zone, the region around a star where conditions are just right for liquid water to exist and consequently, for life to flourish. As the Sun ages and enters its red giant phase, this delicate balance will be disrupted. The intense heat and increased luminosity will likely render Earth inhospitable, leading to the extinction of life as we know it. This prospect is not merely speculative. It is a reminder of the transient nature of habitability in the universe. The question then arises, can life adapt to these changing conditions? As the Sun swells and engulfs the inner planets, including Earth, humanity may face the dire challenge of extinction unless significant advancements in technology occur. This scenario ignites discussions about the importance of seeking alternative homes within our solar system. Mars, for example, has been at the forefront of discussions about potential human colonization. With its thin atmosphere and proximity to Earth, Mars represents an opportunity for humans to establish a foothold beyond our home planet. However, the challenges of living on Mars or any other celestial body are substantial. The Martian environment poses significant hurdles, including radiation exposure, limited resources, and the harsh climate. Scientists are actively researching ways to terraform Mars, creating a more hospitable environment by altering its atmosphere and temperature. While these ambitions may seem far-fetched today, the very act of considering such possibilities showcases humanity's determination to adapt and survive in the face of cosmic changes. As we contemplate the Sun's fate and its effect on habitability, it becomes crucial to think about the ethical implications of space exploration. If humanity reaches a point where we can escape a dying Earth, what responsibilities do we hold toward the planet we leave behind? The notion of stewardship over our home planet must guide our actions as we consider the future of interplanetary colonization. This stewardship includes preserving the delicate ecosystems that have evolved over millions of years and ensuring that our technological pursuits do not come at the expense of the environment. Furthermore, the potential for establishing life on other planets invites questions about the nature of life itself. What does it mean to be a living being? If we were to discover microbial life on Mars or other celestial bodies, how would that reshape our understanding of biology and our place in the universe? The search for extraterrestrial life is not merely about finding organisms similar to ourselves. It challenges our perceptions and expands our definition of life. As we explore the cosmos, we must remain open to the possibility that life can exist in forms we have yet to imagine. The eventual transition of the Sun into a white dwarf also offers a unique perspective on the fate of elements and materials within the universe. As stars evolve, they create and distribute heavier elements throughout the cosmos, enriching the interstellar medium. Our Sun, like other stars, is a factory of elements, producing the building blocks necessary for the formation of planets and life. As it exhausts its nuclear fuel and sheds its outer layers, the material released into space contributes to the cosmic cycle of matter. This recycling process illustrates the interconnectedness of the universe, where the remnants of one star can give rise to new stars and planets, fostering the potential for life. Moreover, the remnants of the Sun will not disappear quietly. They will contribute to the next generation of celestial bodies. The gases and dust released during the red giant phase will eventually cool and condense, forming new stars and potentially new planetary systems. This cyclical nature of stellar evolution emphasizes the idea that death is not an end but rather a transition into something new. The remnants of our Sun may one day serve as the foundation for new worlds, carrying forward the legacy of a star that once sustained life on a small blue planet. As we consider the cosmic legacy of our Sun, we are reminded that humanity is not merely a passive observer in this grand tapestry of existence. Our actions today have the potential to influence the future of life beyond Earth. The decisions we make regarding technology, resource utilization, and environmental stewardship will shape the course of our species as we navigate the challenges posed by the Sun's evolution and beyond. The interplay between the Sun's fate and humanity's future calls for collaboration and unity. The pursuit of knowledge about our universe transcends borders, and as we seek to understand the cosmic forces that govern our existence, we must come together as a global community. The challenges we face in adapting to a changing solar environment require collective effort, innovation, and shared responsibility. Scientific collaboration, whether through space agencies, academic institutions, or international partnerships, will be crucial in addressing the pressing questions of our time. In addition to the practical implications, the fate of the Sun also inspires profound philosophical contemplation. As we face the reality of cosmic change, we are encouraged to reflect on our values, beliefs, and aspirations. The awareness of our Sun's eventual demise can serve as a catalyst for deepening our understanding of existence and purpose. The fleeting nature of life and the universe invites us to cherish the moments we have, to forge connections, and to contribute positively to the world around us. Furthermore, the transformation of the Sun into a white dwarf also invokes the idea of legacy beyond our individual lives. The stories we tell, the knowledge we pass down, are all part of a larger narrative that transcends generations. Just as the Sun's materials may eventually contribute to new stars, our contributions to humanity's collective knowledge will ripple through time, influencing those who come after us. This legacy underscores the importance of nurturing curiosity, creativity, and compassion in our interactions with one another and the world. As we delve into the mysteries of the cosmos, the fate of the Sun serves as a poignant reminder of the beauty and fragility of existence. The journey from main sequence to white dwarf encapsulates not only the life cycle of a star but also the interconnectedness of all things in the universe. Every star, planet, and being contributes to the grand symphony of existence, and as we continue to explore, learn, and grow, we become active participants in this cosmic narrative. The fate of the Sun is not merely a scientific inquiry, it is a profound exploration of existence itself. From the mechanics of stellar evolution to the ethical considerations of space exploration, the implications of the Sun's transformation reverberate throughout our understanding of life, the universe, and our place within it. As we contemplate the future of our solar system, we must recognize the importance of stewardship, collaboration, and innovation as we navigate the challenges and opportunities that lie ahead. The story of our Sun is a testament to the wonders of the cosmos, and a reminder of the interconnectedness of all things. As we gaze into the night sky, we are reminded that the light we see is not just a distant star but a legacy of creation, transformation, and continuity. The fate of the Sun, from its humble beginnings as a swirling cloud of gas to its eventual transformation into a white dwarf, is a narrative that transcends time and space, inviting us to ponder the mysteries of existence and the infinite possibilities that await us in the universe. As we continue our exploration of the Sun's eventual transformation into a white dwarf, it's imperative to consider the profound effects this stellar evolution has on our understanding of the universe and our place within it. The life cycle of the Sun is not just a personal narrative for Earth, it is part of a much larger cosmic story that encompasses the evolution of galaxies, the birth of new stars, and the intricate dance of cosmic materials that shape the universe as we know it. The Sun, classified as a G-type main sequence star, is one of billions of stars that populate our Milky Way galaxy. As it continues its journey through the cosmos, it not only plays a crucial role in the solar system but also serves as a reference point for studying other stars and their life cycles. By examining stars at different stages of their evolution, astronomers gain invaluable insights into the processes that govern stellar behavior, including nuclear fusion, mass loss, and the chemical enrichment of the interstellar medium. In this context, the Sun's impending transition into a red giant and subsequently a white dwarf serves as an illustration of the broader mechanisms of stellar evolution. As stars exhaust their nuclear fuel, they undergo dramatic changes that can lead to supernovae in more massive stars or the gentle shedding of layers in stars like our Sun. The materials expelled during these processes enrich the interstellar medium, seeding future generations of stars and planets with the heavy elements necessary for life. Our Sun, having forged elements like carbon and oxygen in its core, is a product of this stellar alchemy, and its eventual demise will further contribute to the cosmic cycle. This cycle of birth, death, and rebirth of stars is an essential aspect of cosmology. It provides the building blocks for galaxies, star clusters, and planetary systems. As we contemplate the sun's fate, we must acknowledge our role within this grand narrative. The atoms that compose our bodies were once part of stars, and the energy that sustains life on Earth originated from nuclear reactions occurring in the sun's core. This intimate connection to the cosmos invites us to consider the implications of our existence and our relationship with the universe. Moreover, the fate of the sun challenges our understanding of time. The transformations it will undergo unfold over millions and billions of years, far beyond the human timescale. This vast temporal perspective compels us to think about our place in the universe in a broader context. While individual lives may seem fleeting, they are part of a continuum that stretches across cosmic history. This realization can inspire a sense of humility, as we recognize that our actions today may have far-reaching consequences for the future of life and the universe. As we approach the end of the sun's life, it is also crucial to reflect on the technological and scientific advancements that may arise from our understanding of stellar evolution. The study of our sun and its eventual fate provides a foundation for exploring other celestial bodies and the potential for human habitation beyond Earth. The knowledge we gain from the sun's life cycle informs our search for habitable exoplanets and guides our efforts to understand the conditions necessary for life to thrive elsewhere in the universe. Consider the implications of harnessing energy from the sun. As we face the challenges of climate change and resource depletion on Earth, solar energy offers a sustainable solution that echoes the processes of the sun itself. By capturing and utilizing solar energy, we not only pay homage to our stellar neighbor but also create a more sustainable future for generations to come. This transition from fossil fuels to renewable energy is not just a technological shift, it is a philosophical shift that aligns humanity's aspirations with the rhythms of the cosmos. The fate of the sun also invites philosophical musings about existence, mortality, and legacy. As individuals and societies, we grapple with questions about what it means to leave a mark on the universe. The knowledge that the sun will eventually fade into a white dwarf urges us to consider how we want to be remembered and what kind of legacy we wish to create. This contemplation of legacy is not limited to humanity, it extends to the broader ecological and cosmic context. The stewardship of our planet and the preservation of life is a legacy we leave for future generations, both on Earth and potentially on other worlds. In exploring the fate of the sun, we inevitably arrive at questions about consciousness and the search for meaning. As intelligent beings capable of reflection, we possess a unique awareness of our mortality and the transience of our solar system. This consciousness has led us to explore, to question, and to seek understanding. The very act of pondering the fate of our sun and the cosmos reflects our desire to connect with something greater than ourselves. It compels us to seek answers and to forge a narrative that transcends our individual lives. Throughout history, humanity has gazed up at the stars, seeking answers to existential questions. The fate of the sun embodies this quest for understanding. It represents a culmination of cosmic processes that have shaped the universe and our place within it. As we learn about the sun's evolution, we also learn about ourselves. We are connected to the cosmos in profound ways, and the fate of the sun is intertwined with the fate of all life on Earth and beyond. As we consider the future implications of the sun's transformation into a white dwarf, we must also address the potential for human innovation and resilience. The challenges presented by the changing solar environment compel us to pursue technological advancements that could help us adapt to new realities. If we look toward the distant future when the sun has entered its final stages, we can envision a time when humanity has developed the capability to traverse the stars. The dream of interstellar travel, once relegated to the realm of science fiction, may become a tangible reality as we harness our ingenuity to navigate the cosmos. Imagining the future of humanity in a post-solar system era evokes both excitement and trepidation. Will we succeed in creating a sustainable presence on other celestial bodies, or will we fall victim to our limitations? The answers to these questions lie not only in our scientific endeavors but also in our capacity for cooperation, empathy, and ethical decision-making. The journey toward interstellar exploration requires not just technological prowess but a collective commitment to the values that sustain us as a species. In essence, the fate of the sun serves as a reminder of the profound mysteries of existence. It is a journey filled with uncertainties and possibilities. As we navigate the intricate tapestry of life, we are called to honor the legacy of the sun by nurturing our planet, pursuing knowledge, and embracing the challenges of our time. The cosmic cycle of stars will continue, and our sun's eventual transformation into a white dwarf is merely a chapter in the ongoing narrative of the universe. As we ponder the fate of the sun, let us embrace the awe and wonder that accompanies our exploration of the cosmos. Each discovery fuels our imagination and deepens our appreciation for the intricacies of existence. The light we see from distant stars is not just a beacon in the night. It is a testament to the resilience of the cosmos and a reminder of our interconnectedness with all that exists. In the grand scheme of things, the fate of the sun is a story of continuity and transformation, of birth and rebirth, of life and legacy. It invites us to reflect on our own journeys, our place within the universe, and the choices we make as stewards of our planet. The sun's evolution reminds us that while we may be mere inhabitants of a small planet orbiting a relatively average star, we are also part of a much larger cosmic tapestry. This realization is both humbling and empowering, urging us to reach for the stars while remaining grounded in our responsibilities to one another and the world we inhabit. As we contemplate the inevitable transformations that await the sun, we are reminded that while our solar companion may fade away, the stories, memories, and knowledge we create will persist. The cosmos is vast and full of mysteries yet to be unveiled, and our journey has just begun. As we stand on the precipice of discovery, we are called to embrace the unknown, to question, to explore, and to celebrate the beauty of existence. The fate of the sun is not just an endpoint, it is a gateway to new beginnings and infinite possibilities. As we delve deeper into the implications of the sun's life cycle, we must also consider the scientific efforts currently underway to monitor and understand our star's behavior. The Solar Dynamics Observatory, SDO, launched in 2010, is one such mission that plays a vital role in advancing our knowledge of the sun. By observing the sun in various wavelengths, the SDO collects data on solar activity, such as sunspots, solar flares, and coronal mass ejections, CMEs. These phenomena are not only fascinating in their own right, they also have profound effects on space weather, which can impact satellite communications, navigation systems, and even power grids on Earth. Understanding the sun's behavior is critical for predicting space weather events. For instance, a powerful CME can release billions of tons of solar material into space, traveling at speeds of up to 3 million miles per hour. When such a cloud of charged particles interacts with Earth's magnetic field, it can cause geomagnetic storms. These storms can disrupt satellite operations and even create dazzling auroras visible at lower latitudes than usual. The potential impacts of space weather on modern technology highlight the importance of solar research in safeguarding our technological infrastructure. Moreover, as we learn more about the sun, we also gain insights into the habitability of exoplanets orbiting other stars. Understanding the conditions that lead to solar flares and CMEs helps astronomers assess how similar phenomena might affect the atmospheres of distant worlds. For instance, an exoplanet with a strong magnetic field could better protect itself from harmful solar radiation, potentially increasing its chances of hosting life. This connection between solar dynamics and astrobiology emphasizes the interdisciplinary nature of modern astronomical research. As we approach the eventual fate of our sun, it is essential to reflect on the philosophical implications of our expanding knowledge. The sun's transformation from a main sequence star to a red giant, and finally to a white dwarf, serves as a metaphor for the cyclical nature of existence. In contemplating this transformation, we are confronted with fundamental questions about life, death, and the impermanence of all things. Just as the sun will one day relinquish its fiery luminosity, all living beings face their mortality. This awareness can provoke feelings of existential dread, but it can also inspire us to live with purpose and intention. The sun's journey through the cosmos also prompts us to think about the nature of legacy. While individual lives may be fleeting, the contributions we make to knowledge and society can endure long after we are gone. The lessons learned from studying the sun can shape future generations' understanding of the universe and inspire them to pursue their own paths of discovery. As we endeavor to unravel the mysteries of the cosmos, we are also participating in a larger narrative that transcends our individual experiences. In considering the long-term future of humanity, the fate of the sun raises questions about interstellar exploration and the potential for humanity to become a multiplanetary species. As the sun ages and its habitability zone shifts, the need for humanity to seek refuge elsewhere becomes more pressing. Mars, with its similarities to Earth, has long been a focal point for potential colonization efforts. The exploration of Mars and other celestial bodies may soon lead to technological advancements that could enable human habitation beyond Earth. Space agencies around the world are investing in missions to study Mars, including NASA's Perseverance rover, which is searching for signs of ancient microbial life and collecting samples for future return to Earth. As we develop the technologies necessary for interplanetary travel, we must also grapple with the ethical considerations of colonizing other worlds. The question of how to approach the preservation of extraterrestrial environments and the rights of potential indigenous life forms will undoubtedly shape our future endeavors. In a broader sense, the fate of the sun serves as a catalyst for a renewed appreciation of our planet and the delicate balance of life that it sustains. The realization that our sun will one day transform into a white dwarf underscores the urgency of addressing climate change and environmental degradation. As we consider the long-term sustainability of life on Earth, we are called to reevaluate our relationship with nature and adopt practices that protect our planet's ecosystems. This awareness has sparked a global movement towards sustainability, urging individuals and societies to adopt environmentally friendly practices. From renewable energy initiatives to conservation efforts, humanity is beginning to recognize the interconnectedness of all life forms and the necessity of stewardship. In a sense, the sun's life cycle can inspire a collective commitment to protecting our home planet, ensuring that future generations inherit a world capable of sustaining life. As we reflect on the sun's fate and its implications, we are also reminded of the role of art in shaping our understanding of the universe. Throughout history, artists, writers, and philosophers have grappled with the themes of existence, mortality, and the cosmos. The sun, as a central figure in many cultural narratives, has inspired countless works of art and literature, serving as a source of inspiration for creativity and reflection. The relationship between humanity and the cosmos has been a recurring theme in art and literature. The sun often symbolizes life, vitality, and illumination, serving as a reminder of the power of light in a world that can sometimes feel dark and uncertain. As we confront the unknowns of the universe, art becomes a medium through which we can express our hopes, fears, and aspirations, capturing the essence of the human experience. In exploring the fate of the sun, we can also appreciate the value of collaboration and shared knowledge. The study of astrophysics and astronomy is a global endeavor, uniting scientists from diverse backgrounds in pursuit of a common goal: to understand the universe and our place within it. This spirit of collaboration fosters innovation, encouraging the exchange of ideas and perspectives that drive scientific progress. As we gather insights about the sun and its eventual transformation, we find ourselves standing at the intersection of science and philosophy. The questions raised by the sun's life cycle transcend mere scientific inquiry. They invite us to reflect on the nature of existence, the search for meaning, and the connections that bind us to one another and the cosmos. The sun serves as both a literal and metaphorical beacon, guiding us on our journey of discovery. Ultimately, the fate of the sun is a story that is still being written. While we have made significant strides in understanding its life cycle, many mysteries remain. As technology advances and our observational capabilities improve, we are likely to uncover new insights about the sun and its impact on the solar system. This ongoing exploration is a testament to the resilience of human curiosity and our unyielding desire to understand the universe. We are left with a sense of wonder and appreciation for the intricate dance of cosmic forces that shape our existence. The sun, with its vibrant energy and life-giving light, has been a constant presence in our lives. Its journey from a main sequence star to a white dwarf encapsulates the cycles of creation and destruction that define the universe. The mysteries surrounding the Sun's future invite us to engage with profound questions about our place in the cosmos and our responsibilities as custodians of Earth. We are reminded that while we may be small in the grand scale of the universe, our actions resonate through time and space. Each moment is an opportunity to learn, grow, and contribute to the legacy of knowledge that will endure long after the sun has faded into the cosmic twilight. As we gaze up at the night sky, we can take comfort in the knowledge that the stars, including our sun, continue to shine brightly, illuminating the path ahead. The journey of exploration and discovery is far from over, and the stories we create along the way will enrich the tapestry of existence for generations to come. In the grand narrative of the universe, the fate of the sun serves as a powerful reminder that life, in all its forms, is a wondrous and interconnected phenomenon, deserving of our respect, understanding, and stewardship. As we look to the future, it is essential to recognize that the fate of the sun will not only influence the trajectory of our own planet but also has implications for the entire solar system. The sun, as the gravitational anchor of our solar system, governs the orbits and behaviors of all celestial bodies within its reach. Its transformation will create significant shifts in the dynamics of these bodies, from the inner planets to the farthest reaches of the Kuiper Belt. As the sun exhausts its hydrogen fuel and expands into a red giant, its outer layers will begin to engulf the inner planets. Mercury and Venus, which lie closest to the sun, will be completely consumed in this phase. Earth, too, will face extreme conditions as temperatures rise, rendering it uninhabitable long before the sun fully engulfs it. This inevitable fate serves as a poignant reminder of the transient nature of planetary systems and the fragility of life. However, the sun's life does not end abruptly with its transformation into a white dwarf. After shedding its outer layers, the remnant core will cool and fade over billions of years, leaving behind a planetary nebula, a stunning, glowing shell of gas and dust that expands outward from the dying star. These nebulae are not just visually spectacular, they also play a crucial role in the cosmic recycling process. The elements created during the sun's life and the heavy elements formed during its death throes will be dispersed into the interstellar medium, enriching it and contributing to the formation of new stars and planetary systems. This cycle of birth, death, and rebirth is central to the life of the universe. The materials released by the dying sun will eventually coalesce to form new stars, planets, and potentially new life forms. The very atoms that make up our bodies may one day find themselves in distant worlds, continuing the cosmic dance of existence. This connection highlights the shared heritage of all matter in the universe and underscores the profound interconnectedness of life across time and space. In a broader sense, contemplating the fate of the sun invites us to consider our own legacy as a species. As stewards of Earth, we face challenges that require collective action and a commitment to sustainability. The sun's eventual demise reminds us that our time on this planet is finite, and we must take responsibility for its preservation. This stewardship includes addressing climate change, protecting biodiversity, and promoting a sustainable relationship with our environment. Moreover, the pursuit of knowledge and understanding is a legacy that can transcend generations. As we investigate the cosmos and unravel its mysteries, we contribute to a collective human experience that enriches our understanding of ourselves and our place in the universe. The pursuit of knowledge is inherently valuable. It fosters curiosity, creativity, and innovation. By investing in scientific research and education, we equip future generations with the tools necessary to navigate the challenges they will face in an ever-changing world. In the spirit of inquiry, humanity must also consider the ethical dimensions of our endeavors in space exploration. As we expand our reach beyond Earth, we encounter questions about the rights of other worlds and the potential impacts of our activities on extraterrestrial environments. The notion of interplanetary colonization prompts us to reflect on how we engage with the universe and the moral implications of our actions. For instance, as we explore Mars, the potential for microbial life raises concerns about contamination and the preservation of pristine environments. The discovery of life, even in its simplest form, would challenge our understanding of life and existence. It is imperative that we approach exploration with caution and respect for the integrity of other worlds, ensuring that our actions do not disrupt the delicate balance that sustains them. As we venture into the future, the questions surrounding the sun and its fate will continue to resonate, influencing not only scientific discourse but also cultural and philosophical dialogues. The sun has long been a source of inspiration in art, literature, and spirituality, representing vitality, hope, and the cyclical nature of existence. As we navigate the complexities of our relationship with the cosmos, the themes evoked by the sun's life cycle will find expression in creative endeavors that reflect our deepest hopes and fears. In literature and art, the sun has served as a powerful symbol of human aspiration. It represents the pursuit of knowledge, the light of understanding, and the warmth of community. The stories we tell about the cosmos mirror our collective journey through life, and the sun remains a central character in this narrative. As artists and writers explore the mysteries of the universe, they illuminate the profound connections that bind us to one another and the cosmos. In contemporary discussions about the future of humanity, the sun's fate serves as a powerful metaphor for resilience and transformation. Just as the sun undergoes a metamorphosis, so too can humanity adapt and evolve in the face of challenges. The journey from main sequence star to white dwarf is a reminder that change is an intrinsic part of existence. By embracing the inevitability of change, we open ourselves to new possibilities and innovative solutions to the pressing issues of our time. Moreover, the exploration of the sun's life cycle invites us to consider the role of technology in shaping our understanding of the universe. Advances in telescopic and observational technology have revolutionized our capacity to study celestial phenomena. Instruments like the Hubble Space Telescope and the upcoming James Webb Space Telescope provide unprecedented views of the cosmos, revealing distant galaxies, nebulae, and the intricate details of stellar processes. These technological marvels not only enhance our understanding of the sun and its evolution but also inspire future generations of scientists, engineers, and explorers. The pursuit of knowledge is inherently intertwined with human creativity and ingenuity, and as we forge ahead, we must continue to invest in the tools and technologies that enable us to explore the cosmos. The fate of the sun, from its current status as a main sequence star to its eventual transformation into a white dwarf, encapsulates the grand narrative of the universe. This journey serves as a reminder of the cyclical nature of existence and the interconnectedness of all matter. As we contemplate the implications of the sun's life cycle, we are invited to reflect on our responsibilities as stewards of Earth and our role in the ongoing quest for knowledge. The lessons learned from the sun's evolution resonate deeply within us, urging us to consider our legacy and the impact of our actions on future generations. As we explore the mysteries of the cosmos, we find ourselves part of a larger narrative, one that transcends time and space and speaks to the enduring spirit of curiosity and discovery. The sun's fate is not merely a tale of cosmic phenomena. It is a reflection of our shared human experience, a journey that unites us in our quest for understanding and meaning in an ever-expanding universe. As we continue to unravel the mysteries of the sun and its fate, we find ourselves enriched by the knowledge gained and inspired by the potential that lies ahead. The universe is a vast and intricate tapestry, woven together by the threads of time, space, and existence. As we stand on the precipice of exploration, we are reminded that our journey is only just beginning. This video is for educational or entertainment purposes only, and information provided in the video may be incorrect. Like the video and subscribe to the channel for more such amazing videos.